Hey, welcome back. Fall break is obviously over. Had some good weather. Hope you got out and did something special over those days. It's already Tuesday. I was thinking it was Monday, but we're already on Tuesday, so it's a 4-day week. Number one, don't forget to turn in the pizzazz sheet that we had on that very last Friday before fall break. It was 19B. Most kids at school got it done in school and kind of got it turned in before they left that day because it was a pretty quick paper. But if you didn't get it done, make sure you get those answers turned in. Second, just as a reminder, the quarter doesn't start as a fresh quarter. It's a semester now, so we just continue on with whatever your grade was before the fall break. That still is your grade. So it's kind of new. And I'm not sure why ALA went to that this year. This is first time I've seen that. College is always on semesters, but not usually high school. So I haven't found anybody who could give me a good answer. Anyhow, let's get this warm up out of the way real quick. I got the answers here, so if you'll knock that out, I'll show you my answers here on the next page on how I got the answers that I did. Pause the video, do this real quick, and then come back. All right, welcome back. Well, my computer's still having problems because it locked up while we were gone. So, anyhow, we're back. There's the answers I got. For number one, I got 2. Problem number 2, I got -7. You can hardly see my negative sign there. And number 3, I got -5. And 4, I got x is -7. So you can pause the video if you didn't get those answers and kind of see. We had some collecting like terms on several of the problems that were on the same side of the equal sign. And so we're going to get more and more of these kind of problems as this year continues on. And we're going to get actually 2 problems here at a time that we're going to start solving and graphing. So 2 things there is make sure that we get this figured out on how to isolate the variable by using opposite operations. And number 2, if you don't have a ruler, you're going to need a ruler. We're going to do lots of graphing for the rest of this year. So get us some kind of a straight edge. All right. I guess there's the digital form of my answers. All right. Today we're going back to relations and functions to kind of get us started. And I don't know, if I was inventing algebra, I wouldn't call x's and y's so many different names. We're going to come up with like 5 different names for this thing called an x. And so somewhere on your paper, maybe down here, let's see. I'm going to start a list in my classroom that if we have X and we have a Y, there's other names that we're going to come up with these guys. And so we're also going to call these guys, maybe you've heard it in the past, as input. So that's another name for X, and this would be called output. Then today we're going to find out a name for these guys is domain and range. Or maybe you've heard them before in junior high, domain and range. So it's very important that these guys are all the same. X is the same as the input, is also called the domain. The Y values are called output, and it's also another name is range. And we're going to come up with 2 more names for these guys as we go along here. So what today we're doing is we're looking at input, the domains and the ranges, and we're talking about whether it's a function, okay? So here's our first math problem. It says the score system of some track meets, first place is worth 5 points, second place is worth 3 points, third place is worth 2 points, and fourth place is worth 1 point. This scoring system is a relation, so it can be shown as ordered pairs. So you'll notice 2 things here. There's a bracket here, and then there's parentheses here. On the parentheses, 1, 5, if you remember back from your junior high days, if we were graphing that, this is my X value and this is my Y value. And so lots of times in junior high, you make a table. So, and we have our labels here. First place was 1, 2, 3, 4. And then over here, the point system was for first place, you got 5. Second place, you got 3. Third place, 2. Fourth place, 1. Then we came over and graphed these, which in high school, labels are extremely important. They got points on the vertical axis and what place they got, on the horizontal axis. And then this is kind of new. This is called mapping. And so these are my axes on, oh, by the way, back here, this is my x-axis and this is my y-axis, in case you forgot. So we'd come over 1 up 5 to plot that first point. This is called a coordinate called 1, 5, which is also listed up above, and so forth. So there's I come over 1, 5, the next graph or point, I would say 2, 3, 3, 2, 4, 1. Over here, this is a mapping diagram. So these are my x's here in the first box, and these are my y's over here. First place, we put them in usually numerical order, 1, 2, 3, 4. Most of the time we put these in numerical order, 2 is the y's over here. And then what we do is we draw a line from 1 to 5 because it was worth 5 points. 2 was worth 3 points, and etc. So this is called a mapping diagram. Okay, so 3 different kinds of graphs here: table, graph, mapping diagram. So what we're going to do is we're going to take this group of numbers right here. That's why they have it in brackets. And we're going to put them into a table. On this one, they don't really tell us, so we can't label our graph over here, even though I just said labels are important. So we don't know what these numbers represent. We do know, though, that these are my x's and these are my y's. And you don't have to write it on every one like I'm doing here. So my x's go in order from 1, 2, 3. Even though I have more boxes, I just wanted to give you a table that you didn't have to draw it. Now, 1 is associated with a 3 on the y. 2 is associated with the 4, and 3 is matched up with the 5. So if I come over here and graph these, and I want to call my numbers here, just count by ones. 1, 3 is a dot, 2, 4, and 3, 5. Now in this one, I don't want to draw a line because this is what we call a discrete graph, and we're going to talk about discrete and continuous. This is just individual dots, and so I plot these dots on here, and that's going to become important when we're recording domains and ranges. So discrete graph, and I have it, I think, on the next page to kind of remind us what the two are. On a mapping diagram, I take my x's and put them in order here: 1, a 2, and a 3. And then over here, I have for my y's, you can write this here if you want to remind you who's who. First box is the x's, the second box is the y's. And again, most of the time you'll see them in numeric order. I have a 3, 4, 5. The 1 matches up with the 3, so you draw a line to 1 to the 3. 2 matches up with the 4, and 3 matches up with the 5. And that's how you do it. Okay? Hopefully yours came out that way. Now, let's go to domains. This is another name for x's. Range is another name for the y's. Again, I don't know who invented algebra and why we just can't call them the same thing. I mean, just x's and y's. 5 different names we're going to come up for these things called x's and y's. All right, so that's what this is saying. Okay, so let's look at these here. See how they got 1, 2, 3, 4 in brackets. Brackets are very important. Those are all my x's on the scoring system. So we had first place, second, third place, fourth place. Again, brackets, if I'm recording my range on a discrete graph, that would be a graph that just has dots. We got 5 points, 4 or 3 points, 2 points, 1 point. So we put these guys and we would label them. This is back to that very first problem at the track meet. So my domains, I would say domain, a bracket. My domains was first place, second place, third place, fourth place. And my range, if they asked me to find the range, then I would put a bracket and I'd say it's, again, normally you put it in numeric order: 1, 2, 3, and 5, and close my bracket. These are not parentheses, these are brackets. Okay, they're different. Hang on, I gotta turn my light on so I can see what I'm doing. All right, Now, if you notice on this graph, this is what we call a continuous graph. They drew a line. So that means it includes this dot because it's solid, and it includes all the dots and points in between these two dots. Sometimes you will see an open dot. Well, let's draw it right here. Let's say open dot here, and this graph goes this way, and we can come to a closed dot down here. That's a continuous graph, and what happens if we have an open dot, it means it does not include that dot, but 3.1 would be included. So kind of pay attention. You're going to see open dots and closed dots. All right, so that's what that means. So here they're asking us find the domain and range. So we need to write domain. And this one's really kind of strange. So focus here on how to record domains and ranges. I give us the hard one first. Domains means is another word for x's. And so where does my x's start? My x's start at 1 and they go all the way to 3, and it includes all numbers that are in between. So what we do is we put x in the middle, and we say x is greater than or equal to, because it includes 1. Again, we're reading backwards. This is why we did inequalities right before break. And x is all numbers less than or equal to 3. So this is really saying all numbers between 1 and 3. So when we have a continuous graph like this, we record domains in like this. There's too many numbers to list them all. So we use what we call an inequality to help us describe it. Now on our ranges starts right here. We usually start with the lowest number, which is a 2. We put a y in the middle here because we're talking about everything on the y-axis. So y is greater than or equal to 2, and it goes up to 4. So we're going to put 4 over here and say y is less than or equal to 4. So it's really all numbers between 2 and 4. That's how you record a continuous graph. Kind of weird that they started this off with kind of domain and range and recording the continuous one, because I think now they go back to a discrete graph. These are individual points, okay? And they did it right here. You see how -4, -1, 0, they put them in numeric order, okay? So what we want to do is we want to say, okay, here's my domains. And we should know on a mapping that those are my x's. And so here they are. Over here, they didn't put them in order, did they? We're going to, though. And so we have a 1, we have a 2, we have a 5, and we have a 6 bracket. Okay, those are my domains. Now when I go to my ranges, I have a bracket. Over here, -4 is my smallest one, comma, -1, comma, 0. These are individual points. Okay. Over here, 2b, domains, again, are my x's. Bracket, my smallest one is a 1, comma, 4, comma, 8. Make sure you put a commas in between them, because if you just said 148 bracket, it looks like 148. Okay, it's not. It's now, here's a special. When I go to my ranges, I see something special here. When I'm doing my numbers, I only list them one time. So I see I have 2 1s here. I'm only going to list one time, and a 4. Close my bracket. Okay, so there's another rule. If the number happens more than once, we only list it once. Pretty important, because I see a lot of kids mess up on that. You want to put it twice. Okay, we only record it once. All right. Now, if you remember back to functions, functions means that the domain value, which is our x's, is only matched up with one range value. Now, for tables and mappings, it's kind of hard to, you have to really focus on whether it's a function or not. I'll give you a couple clues, but I really like it when they give me a graph and say if it's a function. You'll see why here in a little bit. As I look at this table here, I see 75 is matched up with a 2. I see 68 is also matched up with a 2. And 125 students needs 3 buses. Now, I see that a lot of kids will see all these 2s over here and a 3 and they say that's not a function. But in my brain, because I like graphing, it would look like this, that somewhere my 68 is my smallest number, and then I'd have 1 or 75, and then I'd have 125. If I was to graph this, 68 would be on a 2, 75 would also be on a 2, and 125 would be on a 3. Each number, as I look up and down my graph, has only one dot. If for some reason I had 2 dots like this, then that would not be a function. Okay, if I had 2 dots above each other, because 68 would have an output of a 2 and maybe a 3. So when they say, is it a function, our x's can only have one y value. So this is a function. Now, this is what kids hate. They said, explain. Every domain has one and only one range. You need to write all those words when they say explain why, okay? You'll see it on tests written that way too. Every domain, which is our x's, has one and only one range. That's how you explain. Over here, if I was graphing this one, I'd have, let's just put a graph here, 7, 9, 12, 15. They said 7 is matched up with 0, so I have a dot on 0, and I would also have a dot on -1, which would be over here. So we might, oh, I know. So it'd be 0 and -1, so I go over 7 and down 1, and so there I would have 2 dots, one above each other. Lost my train of thought there for a moment. So if I was graphing this, it would not be a function because I have one dot on top of the other one like I was talking about over here. Now, another clue on the mapping, which is a little bit easier than a table, if I ever see on my X map bubble, if I ever see 2 lines coming off of it, then it's not a function because it's the 7 there has a value of a -1 and a 0. So this is not a function. Now we have to explain. The 7, it'll probably be better to say the domain of 7. I'll scoot this up a little so I can write. Has 2 ranges. I want to say range values of, what were my 2 range values? -1 and 0. You need to list them. Just don't say it has more than one range value. Okay, you're in high school now, so list them. It has a range value of a -1 and 0. Okay, so who do they match up with? Now, here we go on this one. This is what we call, again, a continuous graph because I have one line that just continues forever. So this includes everything. So let's give the domains and the ranges. Let's start with the x's first. I guess it's a continuous graph, I always put x in the middle. It's a solid line going all the way around, so I automatically put my signs like this. X is greater than. So then what I do is I use my pencil, and I start working from left to right on my x-axis. What's my lowest number on my x-axis? This is right there. So it looks like we're counting by 1. So there's -1, -2, -3, -4. So it starts at -4. And even though it's not a straight line, I still have a point right here and here, right here and right here. I mean, it's continuous. So I have all these x values that if I said graph my x values, I'd come up here and graph it, and I could come down here and graph it. So all these x values starting at -4, but it comes up here to 4. I have x values on this graph for anything between -4 and 4. Now when I go to my y values, that's looking up and down. So I go to my very bottom one down here, and I want to automatically put y in the middle here. That's what the R means, is range. They get lazy and don't write the word. So I start at -4 as well, and I work my way up to a +4. Okay, so that's, again, continuous graphs. You write them as an inequality like so. Discrete graphs, we have brackets, and we list each one that's on the x's and to the y's, okay? All right, now they also asked me, give me the domains and ranges and tell whether it's a function or not. Well, it's not a function because I see, if I look up and down, my x value of, let's say, 3, let's go with 3 right here, which is right here. I have a y value of 1 to negative 2 point something, but I also have a y value up here of 2 point something. So my x has 2 y values. And on this one, because it's a continuous graph, you, instead of listing them all, because there's infinity, you can say many domains have 2 range values. Each one of these x values has at least 2. There's one there and one up here. I'll do it in a darker color. If I went to 0, x is 0. Well, I'd have a value down here at negative 4, and I'd have a up here. If I went to 0.1, I'd still have 2. So there's too many to list. And so in this case, we can say the many domains have 2 range values because there's just too many to list. Hardly ever does that happen that it's a circle like that, okay? Now, it's a little bit harder when they give us coordinates like this to decide whether it's a function or not. Remember, a function is any time every x has to have one and only one range value. So x's are our domains, and so what I do when they give me a chart like this, I just go and all I'm looking at is my x's. I don't care about my ranges. And I'm looking at my x's, and if I ever have a repeat, for example, here I have a repeat, 3 and 3. So 3 has a y value of negative 9, and over here 3 has a value of 15. So this is not a function. Do they ask us to say why? Nope. They just ask if it's a function or not. Okay, so if I was plotting that on a graph, I would come over to 3. I like graphs and know whether it's a function or not. And I would have a dot way down at negative 9, which I'm just going to draw it down here. But I'd also have a dot way up on 15. And so my 3 has 2 dots, one at negative 9 and 15. Okay? Can't have that and still be a function. Here I'm looking at my x values. I have a 5, a 6, a negative 4, a 3, a 4. All I care about when I have coordinates and they ask me if it's a function is I look at my x's. If I ever see an x that's repeated twice, then it's not a function. This one is a function because each one happens only once. Again, I'm looking at my x's, 4, 5, 9, 8, negative 6. Don't see any of them repeated. All right. Let's see where we're at. My computer's kind of pausing here for a second. Makes me think it's going to freeze up on me before my video ends here. All right, so here we are again. They gave it to us as coordinates. I'm looking at my x's. Is it a function? I believe it is. All my x's are different. Over here on my b's, remember I'm mapping? I look at my x's and these are my y values. If I ever see 2 lines coming off of this, then it is not a function. They asked me to explain, which I don't know, did they ask us to explain up here? I don't think they did. They just said, is it a function or not? If I did have to explain, and I don't think they said so in the directions, I would say because 2 has, the domain of 2, sorry. The domain of 2 has two range values. Of, what do they got? -5 and -4. And because it was only two range